Okay, Assalamualaikum and hello everyone. Greetings to our lecturer, Sir Haizat and my fellow team members. My name is Nurul Najah binti Azizan. ID number is C18012. Today I would like to demonstrate a simulation on task 1 which were conducted by our group using a MATLAB software that cover the topic of voltage and current harmonics phenomenon in the power system. Okay, this task consists of 4 models. First, a linear load, non-linear load, RL load, and RC load. Okay, the first one is the linear load. Okay, here we are required to design and connect all the blocks. We've got a 3-phase source here, and then a 3-phase voltage and current measurement, 3-phase series R branch, 2 scope, voltage and current scope, and 2 bus bar, and also a power GUI. Okay, then we set the power GUI to a discrete type. Okay, and then we need to run the simulations. Okay, here is the simulation results for the 3 input. And then select the FFT analysis tools. Okay, then we get a nice shape cycle of sinusoidal wave with a total harmonic distortion 12.61%, and for the current harmonics we got a total harmonic distortion of 9.89%. Okay, next we move on to a non-linear load model. Okay, we design a similar model to the previous one, but we add on a resistor here and a current measurement, a 3-phase measurement, a universal bridge, voltage and current scope. Then we run the simulation. Okay, for the voltage harmonics we got a total harmonic distortion about 45%, 45.14% for a complete cycle of sinusoidal wave. And then in the current harmonics FFT analyzer, we can see the fundamental frequency have increased to 17.56%, and the total harmonic distortion has been decreased to 35.77%. Okay, the third one is the RL load model. We add on an inductor and a resistor, 2 resistors here, a scope, current measurement and voltage measurement, and a universal bridge. Okay, then we need to run the simulation. Okay, we got a similar shape of sinusoidal wave, but with a different THD, 12.61%. In current harmonics, okay, we've seen a bit of distortion in the wave. Okay, the THD have decreased to 29.25%. And lastly, for the RC load, we set the value of capacitor for 30 microfarad, resistor about 20 ohm, and here resistor 1 ohm, current measurement, voltage measurement, and a scope. Okay, then we run simulation. Okay, then for the voltage harmonics, we got a THD around 33%, and compared to the current harmonics, there is a bit different. There's a distortion in the wave. The THD value is 29.25%. And lastly, By modifying the previous linear model, we decide to add on a non-linear load and a bus bar which to initiate the harmonics in this model. Here in this voltage FFT analyzer, the result shown is a bit opposite compared to a linear load model, whereby the voltage result faces a bit of noise distortion with THD percent of 94.09%. Meanwhile, the current FFT analyzer shows a clean shape of a sinusoidal wave. Okay, thank you.
Assalamualaikum and hi, good day to Dr. Aizat. My name is Muhammad Hadif bin Zulijam. My ID number is EA18167. Before that, I want to apologize because I am unable to show my face due to my webcam problem. So for this task 2, we are going to use this circuit model to demonstrate the voltage sag as well as the harmonics. So to mitigate the voltage sag and harmonics, we are going to use the dynamic voltage restorer, which is DVR. So the first part, we are going to occur the voltage sag using a double line ground fault, and we are not using a DVR yet to demonstrate the analysis. So as you can see here, there is a voltage sag here. For better analysis, I'm going to use RMS. You can see there is a three-phase voltage sag as at load as well. Load act as a end user equipment, and you can see that there is no voltage supply injection because the activation of DVR. So what I'm going to do, I'm going to enable DVR by closing this short circuit breaker and run. And from the analysis at the bus bar 1, because of the DLG fault, we can see there is a voltage sag. And what I want to highlight is at the voltage load, you can see that there is no voltage sag here because the voltage sag already mitigated by the DVR. You can see there is a voltage supply injection of from the DVR. So there is no, the voltage load, three-phase voltage load has become normal once again. And let's move on to the mitigating harmonics. So for the harmonics, we are going to use a non-linear load instead. So we connect the non-linear load at the bus bar 1 and disconnect the DLG fault. So we can see at the FFT analysis, we can see there is a harmonics in the signal, and the total harmonic distortion is 26.04%. So what we're going to do, we are going to enable our DVR and start to run again and see how the DVR mitigates the harmonics. Okay, after complete running the simulation, we are going to go back to FFT analysis. Here we are going to look at the voltage load analysis at the end user equipment. So you can see there is no harmonics in this signal due to the DVR installation. So basically DVR supply the additional voltage to the harmonics and mitigates the harmonics. And at below you can see the THD, which is the total harmonic distortion, has reduced to 1.89% from 25% something. And that's it. That's how we mitigate the harmonics and voltage sag using dynamic voltage restorer. Thank you very much.